Welcome to this channel IBM classes. In this video session, we'll discuss methods of file. So, before going into the coding part, I'll discuss that what actually the message file is. So, we can see the regular subfiles or the simple subfiles like load all, expandable subfile, a single page subfile where we are um, loading multiple records into a subfile. Now here in this case what we'll do, we're loading the multiple messages or the error conditions or the detail messages into the subfile, so that's called a message subfile. Now what is the difference between a regular subfile or the message subfile? So message subfile actually is you can say that we are not going to load anything into the message subfile. We are not going to clear anything. Here we are dealing with the messages. So we will be removing or sending the messages. So where we will be removing the messages or sending the messages is we will be going to use the program message queue. Sure. So we are utilizing the program message queue here. So instead of clear, so in the subfile, regular subfile, we are clearing the message, clearing the subfile. So in this case, we are removing the messages from the program message queue. Or in um, here, one special thing is here that the message subfile can load itself automatically. So this is the benefit of a message subfile. So if there are messages exist in the program message queue, it will automatically display those messages. So in this case, what we can say that we are not going to load our subfile message subfile, or we are not going to clear our message subfile. So um, let's come to the subfile program or the display file. Then we'll discuss that what actually is required in the message subfile. So we have created this subfile display file. So here we can see that the display size is 24 by 80 ts3. We have used CA03 here, which is F3. So once we press F3, we have used this key for exit purpose. So once we press F3, indicator 03 gets on, and then our program gets exit. So this key is being used for this one. Subfile record format. So we have first taken a subfile record format same as the regular subfile. We can see that here are the three main keywords, or they are in the sequence they are defined actually. So they are in the same sequence only, or if their sequence gets mismatch, the compile error, and the error will come during the compilation time. So here we can see that SFL message record, subfile message record, first keyword, second keyword is subfile message key, third keyword is subfile program queue. So in this case, first one is subfile message record. This one is actually here using this keyword we will be specifying that at which point we will be going to start our message subfile. So the standard line number is 24. So if we take 24, in that case the subfile page is 1, because there is we are not going to display at the 25th position if we're doing so on this one. So what it will do, it will cause the error. Sure. So SFL page would be 1 and SFL size must be greater than SFL page, because message subfile obviously load all subfiles. Second one is the subfile message key. So it's just a key which is used to retrieve the data or the message data, you can say, from a message subfile. Or in case if you don't want the data to be retrieved from the message as a file, message subfile, um, message file, you can say, um, then you have to leave it blank. So either you can hard code the message uh, data in the data section of the send prog or the of the routine from which you will be going to send the message to the program message queue. So um, in case if you don't want the data to be fetched from the message file, so you can leave it blank. Subfile program queue. So the this is actually links the subfile message subfile to the program message queue, where you will be going to send the messages, or either from the program itself by hard coding it, or from the message uh, you can say that message files by retrieving from the message files. So you are going to remove the messages from the subfile program message program queue as well. So it is directly linking your program queue program message queue to your subfile message subfile actually. So in this case you will be specifying the name of the program message queue. If you specify star, then it will be using the program message queue which is currently running actually. So you can also mention the names of the program message queues as well here. So let's come to the subfile control record format here. Here we have defined SFL page as well, SFL size as 4. It's our as per our need. SFL page would be 1 here. So in case if you want the SFL page to be more than 1, then we need to set this either as 23 or 22 in that case. Sure. Here the main keywords are SFL DSP, SFL DSP CTL, and SFL INCHED. So these three keywords are mandatory in this SFL control record format. So these are to be used without any conditioning indicators as well. SFL page, SFL size, we have already discussed. Now SFL end, this is optional, either you can use it or you cannot, you should not. So it's just used to give you hint that there are more than one messages exist in the message subfile. So once this indicator F03 gets off, it means that there are more than SFL end would be active in that case. So we have not used more here SFL end in brackets star more value, because we have set the uh, SFL method record as 24, means the static line as 24. So if we are going to set it 23, then we can use that SFL and star more, because there may be chances that for one message there may be, if in that case SFL page would be 1 and the message would lie in 2 lines. So in that case it going to display it on 23 or 24. But if it is 24, we cannot use star more, because it's going to display on 25, try to display it on 25, which will result in the error. So here we can see that program SFL PGMQ keyword we have used here in SFL control for subfile control format as well. So if we will be using this SFL PGMQ in both the record format, subfile record format or subfile control record format, then in that case we are not going to load the message subfile from ourselves. Pro system will automatically handles it. So I should say that we must include SFL PGMQ in both the record formats, so that we don't need to load the message subfile. So once you write the message subfile record format, message or subfile control record format, then it will automatically load uh, the messages, all the messages onto the message subfile itself without need to code for that actually. So if you're not going to use it, then you need to load the messages in that case. Here we have taken another this record format header, which will be going to display enter first name and the last name and the address. And this is message subfile demo at the first position. So we have taken three input variables: first name, last name, address, as of 10 characters. This is the footer format. Sure. So this is the message subfile actually. Now we have created a program for the message subfile. Let's see that. So our subfile is subfile 5. So we have declared it in C mode, combined mode, and this is a workstation file display subfile. So we are not going to use the subfile record format here because we are not going to load the subfiles here. Sure. So in this case, clearing the subfile means removing the messages from the program message queue, which is attached to it, the message subfile, or sending the messages to the program message queue is just loading. You can say that loading the subfile, message subfile. So here we have used API QMH for what purpose? I'll be telling you later. So first come to the main section of the program. So first thing is the initialization subroutine here. So here we have defined some variables or set the some parameters. SFL PGM queue as star means using programs message queue, message type as star diagnostic, or you can use star info or others as per your uh, need. So here we have used the diagnostic message type must be diagnostic here in this case. Qualified message file name, that is the message file, and the library name here. Set up message file and library here. So in this case, message file is message file, and it resides in library IBM I class 1. So we have created message file using create msgf command, msg file or IBM class 1. So we have used this command to create this message file. Now let's look into this msg file. We have added some messages introducing add msgd command. So if you take F6 here, you'll see that command add msgd. So you'll be going to enter message id, message file names, message data, cvrt here. Sure. So we have created four message IDs here: msg 0001, 0002, 3 and 4 of severity 40. First name cannot be blank, last name cannot be blank, address cannot be blank, and here is and 1. So this will actually replace the data that is coming from the program itself. So in this case, we can see that the message IDs are of 7 length, so it must not be less than 7 length. If you're trying to give it msg1, simple msg1, then you will not be able to give it msg1. Sure. Message 1 for message ID must be 7 characters. So this is the message file here. Now messages to remove means star all here. We are removing all the messages from the program key. So we are giving store all parameter here. Message key would be blank here. Now, so we have set some values in the initialization subroutine. for the message subfile. Now the first thing would be to write the footer record format and then write the message subfile control format. So the first time we do not have any messages in the program message queue which is currently running, so there would be no message displayed on the subfile, or you can say the display file or the display station. Now we are execute formatting the header record format here. So during this one, the subfile formats, or you can say the message subfile will automatically get loaded and displayed. Sure. During this execute format. Now after this, so this is the routine for the display one. So we are not going to load anything here. After this we'll be checking the if F3 is pressed, so we have written the process keyboard subroutine here. So it will just simply check if F3 is on, then set last record indicator is on, and then return from the program. Now if F3 is not pressed, means the enter would be active and the enter is pressed, you can say. So we'll be executing the validation subroutine, which is validate inputs. Now come to this one, validate inputs. So first thing what we'll do is, before displaying the subfile or the display file or the message subfile, you can say, we will be sending the message. We'll be setting the message data or immediate text as error message or something which we want to display on the screen if there is some error occurs, or this message we have provided just because if in any case the system would not be able to fetch the data from the message file, in that case this message would get appear onto the screen. So we are providing the length of message data or immediate text by trimming it to this parameter. Now we are clearing the message subfile, means we are clearing or we are removing all the messages from the program message queue, for which we are using this API QMH means removing the messages from the program message queue. So the first parameter is SFL pigeon queue, whose value is a star, means we will be using the program message queue which is currently active. Call stack counter would be 0, message key would be blank, messages to remove would be star all, means we are removing all the messages from the program message queue which were loaded earlier or which were displayed earlier. Error code is just in case any error occurs during this call, so it will be captured in the error code. So let's go above and see this, the prototype for this one. We can see that this is the prototype QMH RMVPM. This is calling this program. Call stack entry. First parameter is call stack entry, which is just a program message queue name, which is star. Call stack counter would be 0. This is blank. This is star all, and this is the error code, which is of this length and varying size. So we have declared the DS for that error code, and which is retrieving the bytes provided would be negative and bytes available to capture those error messages. Sure. So this was the one. So we have declared the variables as well for them: call stack entry, call stack counter, message key, messages to remove. And error code is already declared below as a DS. So this was the one which is used as a API, you can say, which is a API which is used to remove all the messages from the program message queue. So first we have removed all the program messages from the program message queue. Now we are validating the first name. If it is blank, then in that case we are passing the message identifier as this, and we are calling this QMH send PM API which is used to send the message to the program message queue. So first parameter is message identifier, which is MSG0001 here. Qualified message file name is already loaded in the initialization subroutine, which is message file, and that library name IBM class 1. Message or data or immediate text has been already passed, that is error messages. The length is already passed. This will be used in case the message would not be fetched from the other place. Text will not be find in the will not get retrieved from the message file. Message type would be start diagnostic. SFL PGM queue. So this is the program queue start. We are using the program message queue. Call stack counter would be 0. Message queue would be blank, and this would be retrieved. Means if any case it will have some bytes provided value. So the same thing we are going to do in for this one last name as well. We are passing the message 0 MSG002, and same would be done for address. If it is star blank, message 003 would be passed, and this is end subroutine. Now we'll see the prototype for this API. This one, send program messages to the program queue. Message identifiers of 7 length. Qualified message file name, this is the data, this is the length of that data. Message type, call stack entry, call stack counter, message key, error code. So we have declared them as well below, like this one. Call stack entry, call stack counter, message key, message identifier, qualified file name, message data or immediate text, length of message data or immediate text, message type, error code is already defined. So let's compile this program and call this. We can see that currently we have not inputted in. Now press F3, so we'll come out of this program. Now again call. So F3 is working fine. Now we'll press enter here. So once we have pressed enter here, we can see that we have seen this message, that is first name cannot be blank. So we have retrieved the data from the message file, and which is correct actually. Now we can see that plus is here. It means that there are more messages in the message file. So once we press page down, we will see the second message, last name cannot be blank. So in this case the last name is also blank. Now here is another, we can see that still the plus is um, seen on the file display file. Now press again page down, we'll see address cannot be blank. Now the plus has been gone and blank, there is no records to be displayed on the message of file. So now if we press page down, we will see that roll up or down pass the first or last record in file. So we cannot do page down anymore. Now page up, last address cannot be blank, last name cannot be blank, first name cannot be blank, and page up, roll up or down cannot be blank. So this is the message file which is being displayed on the display file. Now suppose in this case press F3, then again call this. Now we have given this one, like, so first name cannot be blank. We can see that there are no more records stored in the message of file. Sure. Now we'll providing this one. We can see that last name cannot be blank. Now suppose we have provided the last name, you can see that address cannot be blank. Now suppose we have removed this one as well, we can see that last name cannot be blank, and we can see plus at the bottom on the right hand side of the screen. Now we can see that address cannot be blank once we press page down. So now suppose if we remove this one, and suppose this has some value, first name cannot be blank. Now plus is there means some more records, address cannot be blank. So we can see that the validation is working fine. We can retrieve the data very well from the message file and displayed it on the message subfile. So this is a very simple demo or the very simple example of a message subfile. In this case, we have seen that we have not loaded the message subfile, so which is done by the system itself, because we have used the SFL PGMQ on both the record format, that is subfile format as well, and on the subfile control format that actually uh, won't allow us to load that message subfile. Now we have seen that there are two more codes, subfile PGM6 and 7. What does that do actually? Let's see. So we can see that here we have passed MSG004, MSG004. So we have passed MSG004 for all of them, where the message data is cannot be blank, and we have filed the message file name can message data is cannot be blank, and we have used the MSG004 message ID from the message file. So MSG004 actually contains and one, means whatever the value would be provided by the program, it will be get substituted this. So let's compile this program and then call this one. Now press enter. So we can see that cannot be blank. Here they are plus. So once you press down, p cannot be blank, and no more p cannot be blank. So this one, so this is a tree from the, now the message has been gone, cannot be blank. So F3. Now let's see this one. Here we have not passed any message ID, so here we have used cannot be blank message, or we can use the error message as passed blank. Now we can see that we have removed that message file name from here, so we are not passing the message file name and we are not passing the message ID. So in that case, we have hard coded the data passed blank. Now we are calling this one, compiling this one and calling this one passed blank. There are more than one record on the message of file, as plus can be seen. Yes. Sure. So we have seen that there are three ways, either to send the message to the program message queue, either retrieving from the message subfile and using the text, replace the text from the message subfile, and then second one is the using the text which is provided in the program message queue, provided in the program itself, and third one is hard coding the message directly into the program. In that case, we are not using the message subfile. So these are the basic program ways uh, through which we can design. This is the basic way through which we can design the message subfile, and we have seen that we have not declared the output text for the message subfile to display the message that is playing on the message subfile here. So it is actually handled itself by the message subfile. So one more thing goes there, like message subfile is actually a load all subfile, which we have seen that we have not did the coding for the loading part or the clearing part. We just did actually removing the messages and then sending the messages to the program message queue. So if you find my video helpful, then please subscribe my channel, and please follow us on Twitter, and join our group on Facebook. So thank you and have a nice time.